Good morning. Today is March 24, 2020. Our subject, internal combustion engine. And before we proceed to the main topic, which I promised last time, the cylinder head servicing, let us first take up today's topic, the engine valves. So engine valves are poppet valves. They are called poppet valves because they pop in or they move quickly in the cylinder head. So they are placed in the cylinder head and pops out just like a popcorn. When you cook a popcorn, they pop when they are heated. So they in the engine likewise. The valves are called poppet valves because they pop in the cylinder head. So a poppet valve, also called mushroom valve. Okay? So here it is. We have a drawing of a valve. So it's just like an inverted mushroom. Another one. And here are valves. The intake actually being bigger or larger in diameter than the exhaust valve. So a poppet valve, also called mushroom valve, is a valve typically used to control the timing and quantity of gas or vapor flow into an engine. Okay, so why it's a mushroom valve? Because it resembles like a mushroom. So as you see, the mushrooms have a head, and it has also a stem. So our valves in the engine are like those of a mushroom. Okay, so here are our valves. Okay, the larger one being intake, and usually the intake valve is bigger than the exhaust valve. The portion of the hole where the valve meets with it is referred as the seat or valve seat. Okay, so here we can see the portion of the hole, this where the valve meets with it, is referred as a seat or as valve seat. Okay, so that portion is our valve seat. It is where the valve sits down, okay, so that it will seal, okay, the combustion chamber. The valve stem slides through a valve guide. Okay, so this is the valve stem. And where does it slide? It slides through a valve guide. So this is the valve guide. That's our stem. If we look at it at the top view, the valve slides up and down there in the valve guide. So we can see here the valve seat, and we can see the valve guide. Okay. In exhaust applications, a pressure differential helps to seal the valve. Okay, because during exhaust there is an expansion of gas, so that pressure helps the valve to seal the combustion chamber. And in intake valves, a pressure differential helps open it. All right. Pressure differential. Why is there a pressure differential that helps the intake valve? Okay? To help open it. So in intake stroke, as I taught you, there is a pressure differential. There there is a vacuum inside the cylinder, so there is a drop in pressure, so this helps the intake valve to be open. Okay. In addition, poppet valves date from at least the 1770s, when James Watt used them on his steam engines. This is just a short history or background about poppet valves. Okay, so let's go on to the valve operation. So what do we need? We need a valve train, okay, to operate the valves. So a valve train is a device that controls the operation of the valves, in which a sequence of components transmits motion throughout the assembly. So here is a typical valve train. So what do we see here? What are the parts that can we see? We have a cam, then we have a tappet, then we have a push rod, then we have a rocker arm. Okay? These components transmits motion throughout the assembly. So from the cam, when it rotates, when it goes here, when the cam goes there, it pushes this tappet, so it moves up, and in turn it pushes the push rod to go up also, and the rocker arm swings so that it can push the valve and it becomes open now. So when air enters, the way is open so it can enter the cylinder. Or if this is an exhaust valve, if this valve is now open, it will now permit the combustion gases to go out the combustion chamber. Okay, next. Valve trains are built in several configurations, each of which varies slightly in layout, but still performs the task of opening and closing the valves at the time necessary for proper operation of the engine. These layouts are differentiated by the location of the camshaft within the engine. Okay, what are these configurations? We have the overhead camshaft. Okay, commonly abbreviated to OHC, overhead camshaft, is a valve train configuration which places the camshaft of an internal combustion engine of the reciprocating type within the cylinder heads or above the pistons and combustion chambers, and drives the valves or lifters in a more direct manner compared to overhead valves and push rods. Here is our illustration of our overhead camshaft. So as you can see, this is the cylinder head. The cylinder head is placed above the engine or cylinder block. Engine block or cylinder block. So if the camshaft is placed in the cylinder head, it is said to be an overhead camshaft. Okay? Or if it's above the cylinder head, it's an overhead camshaft. All right? Understand? Okay, next. This is the other example of the overhead camshaft. So the camshaft or camshafts, so we can expect that there is a single camshaft being installed, or we have a dual camshaft or two camshafts in a cylinder head. So that's why they said camshafts. The camshaft or camshafts, depending on the design employed, is located above the valves within the cylinder head and operates either indirectly or directly on the valves. Why it's operating indirectly? Because the camshaft is far, at least little away from the valves. So here we can say this is a direct contact of the camshaft to the valve. So when it rotates, the camshaft rotates, and the heel turns into contact with this cap or valve shim, then it will directly push the valve to open against or be away against its seat. All right? So why indirectly? Indirectly because it can use a rocker arm. After the camshaft, we can use a rocker arm, and then the valves are now being pushed by the rocker arms. Understood? And that is an example in our cars. We have a single camshaft, and then we have two valves there, left and right. So a rocker arm is being placed on that cylinder head so that when the cam rotates and pushes the rocker arm pushes the valves. So that is indirectly, because the camshaft did not open it directly. Right? So here are our two camshafts. Okay, we have the cam and block configuration. The camshaft is located within the engine block or the cylinder block, as you know it, and operates directly on the valves or indirectly via push rods and rocker arms. Okay. So this is the typical setup of a push rod engine or a valve train which uses push rods and rocker arms. Okay? So the camshaft is what? It says to be within the engine block or cylinder block. So this is the block here, and that is in the cylinder head. Okay, that portion is in the cylinder head, and this portion is in the engine block. All right? Another configuration, we have a camless engine. Okay? So expect that this engine does not use any cam or camshaft. Okay? A camless or free valve engine uses electromagnetic, hydraulic, or pneumatic actuators to open the valves instead. Actuators can be used to both open and close the valves, or an actuator opens the valve while a spring closes it. Okay, let me explain further here. So as you can see, this is an electromagnetic camless engine. So here, as you can see, the valve is closed. Okay? And we have here springs. The one at the top is compressed, and this one is not compressed or decompressed. And here is the electromagnet, and we have the armature and vane. So when an electricity flows through it, this armature, okay, and vane will be pushed away from that electromagnet. So as you can see, when that was pushed, the valve now was open. Okay? So here we can see that the valve spring is compressed and the other one above is decompressed. Okay? Why it's decompressed now? Because it was already pushed. Okay? In some way, there is a reason why it is decompressed. Okay? But that is for further study. Okay? So, we have understood that this kind of configuration has no camshaft. The valve opened because of this device, which has an electromagnet and an armature. Okay? This layout uses no camshafts at all. Technologies such as solenoids are used to individually actuate the valves. So these are just like solenoids. Another example is we have the hydraulic. So oil now, when it flows through here, so there is a transfer of motion because there is a cam now here and it pushes this piston, and when it compresses the oil or it pushes the oil through that portion or above portion of the valve, the oil pressure tends to move this part, the operating piston, okay? And in turn, it will open the valve. Understood? Okay. Now that we know the operation of the valve, let us go to the valve timing. The valve timing is the precise timing of the opening and closing of the valves. In an internal combustion engine, these are usually poppet valves, and in a steam engine, they are usually slide valves or piston valves. Okay, as we have mentioned, it's a poppet valve because they pop, okay, in the engine. Okay, so in a valve timing, there is so-called valve overlap, which I will explain later on. Okay, with traditional fixed valve timing, an engine will have a period of valve overlap. Okay, so what's a valve overlap? At the end of the exhaust stroke, when both the intake and exhaust valves are open. So that is a valve overlap, when both intake and exhaust valves are open. The intake valve is opened before the exhaust gases have completely left the cylinder, and their considerable velocity assists in drawing in the fresh charge. Engine designers aim to close the exhaust valve just as the fresh charge from the intake valve reaches it, to prevent either loss of fresh charge or unscavenged exhaust gas. In the diagram, the valve overlap periods are indicated by the overlap of the red and blue arcs. Okay, so let us see the diagram, and there is an overlap. There is a period of valve overlap, so indicated by red and blue arcs. Okay, so let's see here, but first let's interpret these things here. Okay, so TDC, we have the top dead center when the piston is at the top. Then we have bottom dead center, BDC. Then we have IO, which tells us that the intake valve is open. So intake valve opens that time. Then we have IC, intake valve closes, IC. Then we have EO, exhaust valve opens, okay. And we have exhaust valve closes, which is EC. So EC. So where is our overlap? Okay, here it is. Okay, so why, teacher, that there is a valve overlap there? So we can see as the exhaust valve, it's open here, right? So the combustion gases goes out, is starting to go out from here. So the exhaust valve will open until there, okay, until it closes here. But before it reaches there is a certain angle that the intake valve will open, okay. So exhaust valve is open here, it's open here up to here, so it's open here, right? At the same time, the intake valve will open. So both valves are open here. So that is called the valve overlap. What is the purpose of the overlap? To scavenge the gas, or to push the remaining exhaust gas. Okay? So until it closes here. Okay? So we have understood that there is an overlap. All right, another example. So here you can see that number 1, this is the intake stroke here. This green line is intake stroke. So the intake valve opens here and it closes there. Okay, so up to here, and then up to number 3. So from here we have 2 first, compression, okay, and there is combustion now happening here, and that is from number 3, that is the power stroke. After power stroke, we have the exhaust stroke, with which the valve will open from this angle, okay? So from this, the exhaust valve is open until there. But at 10 degrees before, the intake valve will open. So at the same time, in this portion, they are open. Both valves are open. But this is very quick or very fast. We cannot see it anymore. Okay, if we're inside the engine. So this is in a low speed and in a high speed. So they have different angles. The valves have different angles in which they will be closed. The exhaust would be here. The exhaust is 5 degrees. It will close after TDC. But this one, in the high speed, the exhaust valve will be closed, or closes. It closes at 20 degrees after TDC. Okay? The intake valve is the same, 10 degrees before top dead center. So they open 10 degrees top dead center. But observe, it will close at 60 degrees after BDC. But here, in a low speed, it will close after BDC at 10 degrees. Okay? So also observe the exhaust valve also. The exhaust valve opens because it's high speed, so it will be open advanced. So here, 55 degrees, it opens now, but this one at 25 degrees before BDC. So it's different. The operation is different, or the opening and closing is different because of the speed. We should consider the speed. So this is a low speed, this is a high speed engine. Okay, understood? Okay, quiz. So that you will be, your brain must be exercised. We will have a quiz. Number 1, what's the function of an engine valve? And then second question, numbers 2 to 3, how are the valves operated? And 4 to 7, what are the parts of a pushrod engine valve train? And then 8 to 9, what are the kinds of valves found in an internal combustion engine? This is very simple. And number 10, what is a valve overlap? Okay, if you understand these things, please do answer this quiz. Or if you don't understand, you can review the lesson again. So once again, this has been Mr. Lim, your teacher. Thank you very much. Have a nice day to all of you, and stay safe always.